Yeah, that's good. Okay. All right. So, well, let's just jump into some algebra then, huh? Algebra. So we did this last time. We found the inverse of functions. When we finished these, right? Or did I say we were going to do this number 6? Did I say we were going to do number 6? I did. So we should do that one together. Yes. Okay. Let's do that together. Here, let me go. Let me make a copy of this. And let me clear the ink from it. Now we have a nice clean slate. Okay, so we're not going to, we did this one. That one's okay. Let's do this one over here. So first I have f of x, I'm changing my n to x, equals -1 plus x plus 2 cubed. And my first step is to change my f of x into a y. So y equals -1 plus x plus 2 cubed. First step to make it an inverse. What is it? Somebody tell me. Just pull off your microphone and tell me. No. What do I need to do?
Yeah. Is it x equals -1 plus y plus 2 cubed?
Yes, that's exactly right. I'm just going to switch my x's and my y's. So I go x equals -1 plus y plus 2 cubed. And that is the implicit form of the inverse. So let's go down a little bit, right? So now I need to solve for y. So the first thing, if I need to get y all by itself, the first thing I'm going to do is get rid of all my debris, get rid of the stuff that has nothing to do with y, which is this -1 here. So I'm going to go +1 on both sides of the equation. So I have x plus 1 is equal to y plus 2 cubed. Now, what I say the majority of students did was they started foiling this out, which was probably really annoying and didn't really help very much because we're still trying to get y all by itself. Although there'd probably be a way that we could do that. Nah, I think we still wind up with trouble, right? So what I want to do is I want to take a cube root of this side and a cube root of that side. Because then this gives me on the left, it gives me the cube root of x plus 1. And now on the right, well, the cube root of something cubed is simply what's under the radical sign. So I get y plus 2. Now that's a pretty key step right there. Is there a question that you want me to, something I should say about that? Everybody's okay with that? Yes. Okay. All right. So now I'm still trying to get y all by itself. I think I'll just subtract 2. So I get y is equal to the cube root of x plus 1 minus 2. Now this minus 2 is not under the cube root. It's separate from the cube root. And now my last step is to change this into f minus 1 of x is equal to the cube root of x plus 1 minus 2. How do we feel about that? Yes? We're good? All right. Now I'm going to show you something that I actually haven't shown anybody yet, but I'm going to show you guys. So I want to look at a graph. And we'll make it a little bit smaller here. All right. So my original function was let's call it y. Let's just make the function. It was -1 plus what was it, x plus 2 cubed. Was that the original function? Yes, help me out. Yes, it was. Okay, great. Well, now I'm gonna type my inverse here. My inverse is the cube root of x plus 1. So I'm gonna write it like this: x plus 1 to the 1/3 power. Whoops, no. Caret 1/3 power minus 2. Now let's take a look at this graph a little bit bigger right here. Do you notice anything interesting about this graph? You should notice something interesting about this graph.
They're the same, but they're going opposite ways.
They are the same, but they're going opposite ways. I'm going to do something right here. I'm going to go y equals x. And I'm going to make that, yeah, that's good. This is the line y equals x. And can you see that these graphs are reflected over that line y equals x? Can everybody see that? Yeah, that's because I'm switching my x's and my y's. If I switch my x's and my y's, I can make this graph, it just reflects right over that line y equals x. And that will be true for all inverses. So it's another way to kind of check whether a function is an inverse of another function, is you graph both functions and you see, well, do they reflect over this line y equals x? Am I switching my x's and my y's? And if they do, then it gives you more evidence that they are inverse. Okay with that? I think so. Okay, let's go back to our picture here. All right, so.
Mr. Jenkins, I had a
Yes.
quick question. The other day we did we just went over the problem that we did the other day. But the one before that, I think you said you were gonna like post a video on how you did it. Did you ever post it?
Probably not. I probably forgot because I didn't write it down. I was gonna on this one here.
Yeah.
Okay, now I'm writing it down. You can see me writing it down here. A2 video on finding inverse. But you know what? Let me just check one thing here. If you got a second, let's go to the everyone folder and let's look at the video index. And let's go to HA2 and let's just take a look and see if I can find something that says inverse. Where is it? Inverse, domain restrictions, horizontal line test, verify the inverse, inverse. All right, so I have a couple of them, but I will just do it. I'll do a couple new ones. Yeah, I'll do that. Okay, away with the video index and back to our next objective, our next issue here. Okay, so two functions are inverse from one another if the composite of those two functions equals x. So the way I describe it is this here. I'm gonna make a, you can see my hand, and here I am, right? I'm standing right here at point x. And one function says take a step forward. And the other function, the inverse, says take a step backwards. Where do I end up? Right where I started. So if I start at x and I have a function that says go that way and then do the inverse, which is go that way, I wind up back at x. So if I take any function and if I take two functions and I take the composite of those two functions and the answer turns out to be x, then I know that they are inverses. All right, well, that was a lot of stuff, but let me just write it down here and then we're going to see it on a problem. So if f of g of x equals x and g of f of x equals x, whoa, dude, stop. How did that happen? Pushing the wrong button. Equals x, then these two functions are inverse. So let's take a look at a problem. So I want to verify that these two functions are inverse. So let's kind of hide this stuff so that we can do it together. But by the way, you know that the test on this was put off till Wednesday, right? Everybody saw that? Yeah, we're not having it on Monday. It'll be on Wednesday. Okay. All right. So here I have f of x, and here I have g of x, and I want to verify, I want to prove that these are both inverse, that they're inverse functions of one another. So let's do f of g of x. So I'm going to take g of x, which is 4/3 x plus 8, and put that as my argument into f of x. So f of g of x would look like 3/4. Now my x is going to be 4/3 x plus 8. And then I have minus 6. So can you see that my x here for f of x, I substituted g of x. That is the argument of my f of x. Now, I want to make sure everybody understands it. This is like it's a complicated step. And then I still had to subtract 6. Are we okay with that?
Mr. Jenkins,
Yes.
how did you know that you had to like put g of x into f of x instead of the opposite way?
Oh, that's a good point. That's a good point. Because the reason I did that was because f becomes before g in the alphabet. So I usually do f of g of x, and then I'll do g of f of x.
Does it matter?
They both have to be true, but honestly, I've never found a case where they weren't. So when I actually ask you to do it on a test, I'm going to say, show one or the other. You don't have to do both.
Okay.
But we're going to do both right now, just so that you can see that it works.
Okay.
Does that work?
Thank you.
Everybody good with that? Okay, good. All right. So let's simplify this. I'm going to take my 3/4 and I'm going to distribute it. Now, I have an important question. 3/4 and 4/3. Wait a minute. I got to get my my random integer magic bowl thing here. So I'm calling on Marissa. I'm calling on you. All right.
Okay.
What do I call 3/4 and 4/3? There's a name for their relationship. What is it?
I don't know.
Okay, that's fine. We'll ask Joanna, what's their relationship?
They're reciprocals?
They are reciprocals, right? I flipped them, right? Reciprocals. Remember the word, okay? So if two numbers are reciprocal, it means that their product is always equal to 1. So we can see that here pretty easily. If I multiply 3/4 times 4/3, the 3's cancel out, the 4's cancel out, and I'm just left with x over here. And then if I multiply 3/4 times 8, Well, that gives me plus 3 times 8 is 24/4, and then I still subtract 6. And 24/4 is the same as 6, isn't it? I can simplify that to 6. So I get x plus 6 minus 6, and I find out that f of g of x is equal to x. So I'm halfway towards really verifying that these two functions are inverse. Let's do g of f of x. So I'm going to take f of x right here, and I'm going to make that the argument for g of x. So I'm going to have 4/3, whoops, come on. 4/3 times, I'm going to substitute this in right now, 3/4 x minus 6 plus 8. So 4/3 times 3/4, that's a reciprocal. So I have x, and 4/3 times -6 would be -24/3 plus 8. That's x minus 8 plus 8. It's x. So g of f of x is also equal to x. These two functions are inverse of one another. How do you feel about that? Pretty clear?
I just have one quick question.
Sure.
So on the test, if you ask if they're inverse of each other, we have to do g of f of x and f of g of x you have to do both of them, right? Or just one?
I'm going to just tell you to do one.
Okay.
Yeah, I'm going to tell you to do one, so you'll pick whichever one you think looks easiest.
Okay.
Does that make sense? Okay, good. Okay. Well, they are inverses, okay. So why don't you guys try this one? Do f of g of x. Yeah, do f of g of x first. Try that. So f of g of x. Give it a shot. So you're ready? Not quite? Okay. Another minute or two. Raina, I'm going to ask you to help with this. You just came up on the magic bowl, so you may as well be ready if you're there. Are you there?
Yes, I'm here.
That's good. Okay. So hang on a minute, and then we'll ask you to do it.
I feel like I did this wrong though.
Well, that's okay. You'll walk us through it and we'll find out how you did it wrong. Then we'll all applaud for you. We applaud when people do things wrong. It's good.
Oh, Mr. Jenkins,
Yes.
did you hear about the UC's waiving the requirement for SAT and ACT for the 2021?
I did hear about that.
That's great.
I think that is pretty good. Yeah, I agree with you. I mean, you know, they were thinking about getting rid of that anyway, so maybe this just kind of pushed them over the edge, and you know,
hmm
yeah. What a mess, huh? I'll tell you though, you know, I'm reading through the survey that you guys completed, and it's very difficult to read the seniors' disappointments without just wanting to start crying. You know, I mean, it's bad. They're really,
I agree. Yeah.
they're getting the short end of the stick here. Yeah. All right, Raina, you ready to help me?
I think so.
Okay, give it a shot. How did you start out with?
So I substituted x for the function of g of x.
Okay, so what did it look like?
I got 3 times x minus 1 over 3 plus 1.
Oh, that looks pretty good to me. Okay, so what'd you do then?
I canceled the 3's out.
I think that's a great idea. So now you have x minus 1 plus, you know, those minus ones, they really are throwing me for a loop. So you have x minus 1 plus 1.
And then
which is equal to?
And then I got x.
And so there you go. Why did you think you did it wrong?
I don't know.
Okay, but you see you did it right? Everybody agrees you did it right? Yes? Okay, so everybody unmute. Okay, now we can applaud. Good. Okay, thank you. You can mute back up again. All right. So let's see. Who's going to help me do 24? Sydney, will you help me do g of f of x?
Okay. Can I do it on paper first and then do it?
Yes, you can. Ready?
Okay. So I have a question about setting it up. So I set it up like 3x plus 1 minus 1 over 3. Is that?
So you said that you took this right here.
Yeah.
And you stuck that in for x right there, right? So you have 3x plus 1 minus 1 over 3. Yeah, that looks right to me.
Okay.
Okay, so now what's my numerator? How do I simplify my numerator a little bit here?
Well, you would get rid of the 3's, right?
Not yet.
Okay.
First, we need to get rid of the 1's.
Yeah,
Can we get rid of these 1's?
Yes.
So now I have 3x over 3, right?
And then the 3's.
And what am I left with?
X.
There we go. So they're inverse. Either way, it shows that they're inverse. Are we good with that?
Mhm.
All right, good. They will get more complicated. Oh, boy. So let me see. What's the one after this? Let's see here. Yeah. You want to do this one by yourselves? You want to get into groups, or you want to do it together?
Together.
Want to do this one together? All right, we'll try it. It's not so tough. It just looks intimidating. It's not. So, all right, so we'll use the magic bulb, work on it together. So number 13. Abby, I want to do f of g of x. How should I set it up? Are you there? Yes, you are. Oh, I think you're there. Maybe Abby had to leave someplace, huh? All right.
Her mic isn't working.
Her mic isn't working. Okay, fine. Then just hang on, Abby. You're relieved here. So let's see. Helena, how would I set this up?
So you would do f of g of x is equal to the cubed root of 1 plus 2x to the third over 2.
You missed something.
Oh, minus 1.
Very good. Minus 1 over 2.
And then you like do that equation, which I don't know how to do.
You don't know how to do this?
My brain can't figure it out right now.
Okay. Can I guide you along a little bit?
Sure.
If I have 1 plus 2x cubed minus 1, can I get rid of these parentheses? I'm not multiplying this. I'm just subtracting it. Can I get rid of those parentheses?
Yeah.
So if I have 1 plus 2x cubed minus 1, can I get rid of the ones, right? 1
Yeah.
minus 1 is 0, right? Are you good with that?
Mm-hmm.
Is everybody good with that? Yes? Okay, so now I'm left with the cube root of 2x cubed over 2. You wanna speculate what I should do here, Helena, or you wanna?
Well, you cross out the 2's.
I can cross out the 2's.
And then the cubed root of x cubed is x.
Very good. Yeah, it just looked intimidating. It wasn't that intimidating. Just step by step. Let's try the other way. Oh, wait, I didn't want to do that. I want to do, I want to clone this. And I want to get rid of the ink. All right, let's try g of f of x. So, Alex, can you help me set it up?
I can try.
Good, go give it a shot.
All right, so is it 1 plus 2 times the cube root of x minus 1 over 2?
Cube root of x minus 1 over 2. Almost, you're forgetting one thing.
Oh, squared, or cubed, sorry.
Cubed, right? Very important thing. Without that thing, we're in deep trouble, right? Okay, so Alex, what is the cube of a cube root?
Just, is it like 0 or 1, or wait?
No, so if I have the cube root of p cubed, what's that equal to?
1
No.
or 0?
No.
I don't know.
Okay,
I don't know.
so the cube root, if I have a cube root and I cube it, those are what we call inverse operations. It's just like if I had the square root of p and I squared it, can you see that that's equal to p? Cube root of p and I cube it, it's equal to p.
Oh, okay, that makes sense.
Right? If I take the 8th root of p and I take it to the 8th power, it's equal to p. Is everybody okay with that? Yeah, okay, great. So then Alex, looking at this piece right here, what is that equal to?
X minus 1 over 2.
X minus 1 over 2. And I'm multiplying that by 2. And then I'm adding 1, correct? Are we good with that, Alex? Yeah?
Yeah.
Okay, so what do I get when I multiply 2 times x minus 1 over 2?
2x minus 2.
Make your life easier. Instead of doing that, why don't we just like cancel out the 2's?
Oh, yeah. I was thinking about dividing them after. That makes sense. So.
Are you good with that? Okay,
Yeah.
so now I have 1 plus x minus 1, and I wind up with x. So either way I do it, I have the inverse. Okay. Yes, okay. Question? Somebody want to ask me a question? Hearing none. All right, so I'm going to send you off into groups. I'm going to make them up right now automatically here. And I think I'm going to do that. Breakout rooms. And oh, so first write down the problem, okay? Because I won't be able to share it with all the groups at once. So write down the problem here. I have h of x and f of x. And I want you to tell me whether or not they are inverse of one another. Got them written down? Yes? Okay, so let's send you out. Come on, trying to send you out into breakout rooms. Oh, I don't know. There we go. Off you go. Want to work it on your own, Nicole?
Yes.
That's fine, totally fine.
Thanks.
Sure. How are we doing?
Okay.
Doing okay?
We're trying.
All right, all right. That's all we can ask for.
Yeah.
Okay.
How we doing over here?
I got it. Marissa is refusing my help.
Okay.
Well, yeah, I'm confused.
I'll let you guys work that one through.
Oh, wow.
Unless you need some help. You want some insight here?
Yeah.
Yeah. Okay. So let's see here. I will get you started on it. You're looking at my screen now, right?
Yes.
Okay. So let's do f of h of x. Marissa, how should I set that up?
So that'd be F. No, that'd be this that one. Well, wait. Okay, wait. Hold on. You're putting H into that one, so it'd
Exactly
be
right.
3 and then square root.
Cube root.
Cube root. Sorry.
Uh-huh.
Of negative, and then parentheses negative x cubed plus 2, and then close parentheses plus 2.
And that's all under this cube root, right?
Yeah.
Okay. Can you work it from there?
I think so. I just don't really. I think what throws me off is just the cubed root.
Okay. Well, cube root is just it really doesn't work any different than a square root, except that it's 3 times instead of 1. But let me ask you a question here. If I distribute this negative sign inside, what does this then become?
Positive.
Okay, so now I have the cube root of x cubed, positive x cubed, and what about there?
-2.
Is it you good with that?
Oh, I know why I was confused. I forgot to add the +2 like on the right side.
Yeah, that'll
Because I was like,
yeah.
there's just a -2 here.
Yeah.
Because
Okay.
I got x. Okay, I'm done.
No, you're not. That was good. All right. Right. I'll see you in a bit.
Okay. Well. How the turntables.
How are we doing in here? Are we doing okay? Yes? Okay, good. I'll call you back in a minute.
Like
Doing?
on your
I didn't hear anything you said, and you just saw me pop in. I don't know what it is, so.
He was just talking about my duck.
Your duck.
My duck at my house.
Oh, your deck. I think you said your duck. I think you have a duck. No, your deck. All right. Are you guys doing okay on the problem?
Yeah, we finished.
You finished? All right, then come on back to the main room. I'll be there in a minute.
Oh, wait, go back.
What?
Oh, never mind.
You can just say leave breakout room or something like that. So that was 4.
I don't know how to leave. Wait, do I? Okay.
5. What are we doing?
Okay. I think I did something, but I don't know if it's the right something to do.
Well, then I'll tell you what. How about we're going to regroup in a minute here, and I'll ask you to walk us through what you did. Is that acceptable?
Yes. Okay.
All right. If you made a mistake, who cares? You know.
Okay.
We'll applaud for you. All right. I'll call you back in just a sec.
Okay.
Are you sure I can't use my phone? I need to make an important
Okay, so let's close all rooms and give them 30 seconds to come back. All right, looks like we are back. So, so Clark, you there?
Yes.
Okay, so you want to, let me do this, get rid of this here. You want to tell us what you did, and I'll write it down. How did you get started? Were you doing f of h of x or h of f of x?
F of h of x.
Okay, so what'd you do?
So I put negative x cubed plus 3 as x in f of x. So I had the cube root of negative parentheses negative x cubed plus 2 plus 2.
That's looking pretty good to me.
And then it was easier for me to make the negative a -1. So like I know that that's what that is, and distributed it. So then it became the cube root of positive x cubed minus 2 plus 2.
Mm-hmm.
And then the 2's equal 0, so they cancel out. And it was just the cubed root of x cubed. So I got x.
Looks good to me. That work for everybody? Yeah? Wonderful. That's good. All right, let's okay, we're gonna do this one. We're gonna do this one together. So, but definitely get out your pencils and keep them sharp, because this one has some arithmetic that can throw you off a little bit. Okay, so I have g of x equals that, and I have f of x equals that. So,
Mr. Jenkins,
yes, please.
we can't see your screen.
Oh, you know what? You can't see my screen. You guys got to help me with that. I forget. So you didn't even see what I did with Clark, did you? Was what Clark did okay? Did everybody get that? Because I wasn't sharing my screen. Wait a second here. Okay, everybody got what Clark did, even though I wasn't sharing my screen? You want to take a look at it again? It was this right here. I will print these problems off and I will email them to you. Okay, so I'm gonna write that down. So to print today's problems. Okay, so let's take a look at this one. Now you can see my screen, right? Okay, so I'm gonna again start with the first letter of the alphabet, and so I'm gonna go f of g of x. So I'm going to take g of x here, and that's going to be my argument. So I'm going to substitute that in right there for x. So I'm going to have 3 divided by negative, and I'm going to use a parentheses here. So negative be negative 3 over x minus 2 minus 3, then minus 3 again, and then the whole thing plus 2. So you know what? Let's try and change this a little bit. So negative 3x minus 2 minus 3, that is my g of x right here. And I substituted that in for that negative x. Looking kind of ugly, yeah? Yeah, okay, but everybody sees what I did, yes? Okay, so let's start using a little bit of arithmetic here. So I'm going to see if I can simplify some of this stuff down here. So I have 3 divided by, I think I'm going to start by distributing this negative sign. So I got 3 over x minus 2. That's positive because the negative sign distributes to that. And then plus
Wouldn't it
3.
be x plus 2?
Well, that's a really good question. So if I have, let's do that off over here to the side. If I have negative 3 over x minus 2, and I make it negative, that negative is going to just take out that negative. Let's use a different example. Let's say I had negative 3 over 4, and I make it negative. Do you agree that it's going to be positive 3 over 4? Yes? Okay. Or I could take negative 3 over 4 and I could make that into negative 3 over 4. Or I could make it into negative, I can make it into 3 over negative 4. And if I put a negative sign there, it's only going to affect either the top or the bottom. It's not going to affect both. Am I clear here, or am I confusing things more? Help me out.
It's clear, we got it.
You sure? Okay. All right. So, I used that negative sign and I got rid of that negative sign, and then I distributed it over here to the minus for the 3, and I get plus 3. And then I have minus 3. And then this whole thing is plus 2. So I'm beginning to simplify a little bit. Well, I can see that I have a plus 3 and a minus 3. So those are going to cancel out. So now I'm going to have 3 divided by 3 over x minus 2 plus 2. Is that okay with everybody? I'm not distributing this minus 3. It's just a subtraction. So I have, a plus b minus c. I don't really need the parentheses. There's no multiplication going on there. Okay. So I have a 3-layer fraction. Cannot have 3-layer fractions. Not allowed to have 3-layer fractions. So if I want to get rid of a 3-layer fraction, I multiply the denominator by its reciprocal, and I multiply the numerator by its reciprocal. Well, by the reciprocal of the denominator. I'm multiplying the denominator by its reciprocal because, and we're going to ask this of Brooklyn. Any number times its reciprocal is equal to what?
1.
And so if I multiply my denominator by its reciprocal, I'm going to end up with 1 in the denominator. And that's what I want. I want to get rid of the denominator. But if I do it to the bottom, I got to do it to the top. So now these cancel out. And I am left with 3 times x minus 2 over 3 plus 2. Well, that's making me kind of happy because I got a 3 here, and I can cancel out that 3 there. So I have x minus 2 plus 2, which gives me x. So the tricky thing with these is that I will frequently end up with multiple layer fractions, either 3 or 4 layer fractions. And I have to, once I clear out whatever debris I can clear out, I have to kind of get rid of those 3 and 4 layer fractions before I can really work the problem well. So why don't you, yeah, we got enough time to do this here. Why don't you guys just right here in the group here, try to do, I'm going to make this so that we can see it better. Clone the page. And then let's get rid of the ink. try doing g of f of x and see how you do. All right, give it a shot. And if you have a question while you're going along, you know, call out to me and we'll resolve it. We can even go into a breakout room if we want.
Mr. Jenkins, I have a question.
Yes.
I'm just not really sure where to, like, I have the original equation written out, but I don't know what the first thing to do is.
So what do you have written down?
Oh geez, I don't even know how to say it. Negative 3 over negative x minus 3 plus 2 minus 2.
This is what you have here for g of f of x. That's your first step. You took f of x right here and you stuck it in right there. Is that right?
Mm-hmm.
Do you still need the minus 3?
I'm sorry?
The minus 3?
Wait. Say this again.
So you don't, after the fraction, don't you need to subtract it by 3?
You're right. You're right. Thank you very much. I forgot that part, right? That's what you're getting at, Bridget? Yeah. Okay. You're right. You're right. I missed it. Okay. So Brooklyn, the denominator here is kind of messy. What would you do to kind of make that less messy?
I can't see it. I don't know.
Okay, so I'm going to ask you a question. If I have A plus B minus C, is that the same thing as A plus B minus C? Do I need the parentheses?
No.
I do not need the parentheses. I only need the parentheses if I'm multiplying. If I'm adding and subtracting, and the parentheses might be nice to make it easier for me, but I really don't need them. Okay, so if I get rid of these parentheses here, what do you see?
You can get rid of the 2's.
Okay, do that and see what happens.
Can I cancel those 3's?
Not yet.
That's what okay, that's what I thought.
Not yet. So do what you have to do to get rid of a 3-layer fraction. So Sandra, you there?
Yeah, I'm right here.
Okay, good. So how do I get rid of this 3-layer fraction? Can you tell me?
You multiply the denominator by its reciprocal.
Okay, so I'm going to go negative x minus 3 over 3, and then what?
And you do the same thing to the top.
Awesome. Negative x minus 3 over 3. So that goes away, right? And so Sandra, what do I have now in my numerator there? Can you help me simplify that a little bit?
Would it be, I mean, is it negative 3x?
Okay, so first, I still have this negative sign over here. So you're gonna go negative 3x.
Wait, can you cancel out the 3's?
Yeah, I think that's a little bit better. I think that make it much easier, right?
Yeah.
Right, so I'm gonna cancel out my 3's right there. And now what do I have?
It'd be negative x minus 3 minus 3.
And I still have this negative sign right there, right?
Yeah. So
Okay, so Sandra, what do I got now?
positive x plus 3 minus 3.
Yeah, and so what does that work out to be?
X.
There you go. Kind of a puzzle, kind of an easy, kind of a, oh, it's just so much fun. It's so much fun arithmetic. Yeah. Does it make sense? Yes? So do some practice problems. See, today's Thursday. Oh, yeah. So on, I guess we're Monday. We'll work a couple of, we'll actually work one more of these problems, and I'll answer any questions that you have on 6.1 and 6.2. So come up with some questions, and we'll probably move on to 6.3 just to kind of touch on it a little bit, and then so you'll be ready for the test on Wednesday. Sound good? Yes? Okay. Go to lunch, spend the rest of your day. Have fun, do whatever you do. It looks like it's a nice day
Thank
outside.
you.
All righty. We'll see you guys later.
Thank you.
Thank you. Judy, did you disappear? Are you okay? Oh, your microphone isn't working, so you don't know why. Okay.